Dear friends and my dear viewers, in today's topic we are going to discuss about atmosphere, its component and its structure. So my dear friends, if I will ask you a question, that which is the following thing which is very needy and very essential for our living, if it will insufficient for even a minute, we cannot live. So many one will, you will answer differently, like someone will answer food, someone will answer water, but these are the things which are necessary for us. But it does not make sense that if they will be insufficient for 1 minute or 2 minutes, then we cannot live or we cannot survive. But the main thing is air. If air will be inadequate or insufficient for even a minute, then many of the people, crores of people, will die due to the insufficiency of air. So air is the one of the most rarest and god gifted things that we have got in our home planet Earth. So now we are going to talk about this. And air exists in the blanket of Earth, which is atmosphere. Now the question arises, what is atmosphere? Atmosphere is nothing but a mixture of different gases which makes a blanket. Different gases, different dust particles, water vapor, it just makes a blanket around the Earth, and it saves us from extraterrestrial things just like solar radiation and many of external components like cosmic waves. And it also makes survival for all the biological activities inside the Earth by providing the essential components like CO2, nitrogen, oxygen, etc. Now my friends, the 99% of atmosphere mass is completed when we go with the height of 32 km from the surface of the Earth, and rest 1% of the atmosphere mass is completed towards the next level after the 32 km. Now we are going to discuss about its different component. So what are the composition of atmosphere? So many atmosphere is composed with many of different materials. As I said before, it is composed with dust particles, water vapor, different gases, and many compounds also, like ozone, O3. And these all are situated at different levels. Like if we will go 120 kilometers above our Earth surface, then you will can't find oxygen anymore, and 90 kilometers above, then you cannot find carbon dioxide and water vapor. Even these two are very essential for our livingness. So all the different gases and all the different element are the composition of atmosphere, but the only thing is that they are situated at different levels. ये सभी जितने भी हमारे एटमॉस्फेयर, जो भी हम चारों तरफ देखते हैं, जो भी धूल मिट्टी वगैरह देखते हैं, वो सभी एटमॉस्फेयर का ही हिस्सा है, लेकिन यही है कि ये डिफरेंट लेवल्स में सिचुएटेड है. दीज आर सिचुएटेड इन डिफरेंट लेवल्स. Now we are going to talk about gases. So gases, in the first we are going to talk about carbon dioxide. So CO2 is a very important meteorological gas, which is very not, we can say it, which is very important for our health, but it is important for the plants, and also it is a important meteorological gas. Like, see what carbon dioxide do in the atmosphere. It blocks the it blocks the internal terrestrial radiation from going outside the Earth's atmosphere, but it is transparent to external radiation that comes in the Earth. ये क्या करता है CO2, मैं आपको समझाता हूँ. जैसे मानो जो भी सन से हार्मफुल किरणें आती है, रेडिएशन आती है, CO2 मेक्स ट्रांसपेरेंसी फॉर देम टू कम इन द अर्थ. ये अर्थ में आने के लिए CO2 जगह दे देता है. जो CO2 बोलता है, वो बोलता है कि आप आ जाओ, जो बाहर से आ रहे होते हैं, जो हार्मफुल रेडिएशन रहता है. लेकिन जब ये यहाँ से रिफ्लेक्ट होकर वापस जाने लगती है, तो CO2 एक्ट्स एज अ ओपेक थिंग. ये उस टाइम पे जितने भी हार्मफुल रेडिएशन उसको रोक देता है, और इसीलिए फॉर दैट रीजन ग्रीन हाउस इफेक्ट राइजेस. लाइक जो ग्रीन हाउस गैस इफेक्ट है, वो और भी बढ़ते जाता है. दैट्स व्हाई वी आर टोल्ड दैट हमें CO2 का एमिशन कम करना चाहिए. दैट्स व्हाई वी आर टोल्ड दैट वी हैव टू reduce the CO2 emission. And many different types of government from all over the country are trying to reduce this, because it is a very important meteorological condition. And why CO2 is more important? It is important for the survival of plants. Like plants makes their food from CO2, and after then we get oxygen and glucose after the formation of the photosynthesis reaction, after the photosynthesis reaction take place, then we are able to get our glucose and oxygen requirement. But how it is possible for the plants? It is possible only in plants if they will get carbon dioxide. Also in the atmosphere, a compound gas which is O3, ozone, is the formation of ozone takes place, in which the oxygen from two oxygen separates, and the oxygen separates is combined to that another two oxygen and make O3. That is very important for our atmosphere because it protects us from ultraviolet rays that comes from sun. तो हमें जितना भी जो गैसेस प्रोवाइडेड हैं जो एटमॉस्फेयर के द्वारा, उसका हम लोगों को प्रोटेक्शन करना चाहिए. एंड इन द रिसेंट टाइम्स वी आल्सो हैव विटनेस्ड दैट इन द कोरोना टाइम द ozone layer was recovered, but after the pandemic has been slowed down, the removal of ozone layer is now happening again, so we have to focus a lot on it. And now what we are going to next topic is the water vapor. So water vapor is also a major constituent in the atmosphere. It decreases with the high in altitude. जैसे जैसे हाइट बढ़ते जाता है वाटर वेपर्स कम होते जाते हैं. जैसे इक्वेटर्स के पास और जो ट्रॉपिकल रीजन्स, इन द ट्रॉपिकल रीजन्स इट कंटेन्स 4% of the total air volume, while in the polar region, tundra region, it constitutes less than 1%. Now how it happens? See, in the equator or tropical regions, the heat comes straight and the land or water heats quickly rather than the tundra polar regions or temperate regions. It makes that the water vapor condenses quickly, means it evaporates quickly and condenses in the clouds. So more the water vapors, then more the amount of that water vapor in the air. So it consists more in the equatorial region rather than the polar or tundra region. So now these are situated at lower levels, but it can get the height with the convectional air current. It can get height to the it can go more height with the help of convectional air current. It has also very important role in our atmosphere, that it does not allow to pass the insulation of the earth. जो अर्थ की गर्मी होती है ना, वो एटमॉस्फेयर से बाहर नहीं जाने देता है, एटमॉस्फेयर से बाहर नहीं जाने देता है ये वाटर वेपर्स के पार्टिकल्स. और ये वाटर वेपर के पार्टिकल्स मेक्स अ बैलेंस बिटवीन द आउटसाइड रेडिएशन एंड द अर्थ्स ओन इंसुलेशन. इसीलिए इंपॉर्टेंट है फॉर आवर लिविंगनेस, हमारे अर्थ के लिए, हमारे वेल बींग के लिए ये वाटर वेपर इज ऑल्सो इम्पॉर्टेंट. नाउ वी आर गोइंग टू टॉक अबाउट डस्ट पार्टिकल्स. सो डस्ट पार्टिकल्स ऑल्सो कॉन्स्टिट्यूट अ मेजर पार्ट in our atmosphere. Atmosphere has a plenty of a space which makes dust particle to occupy into that, and the dust particle formation is highly in the tropical regions because of dry winds rather than the regions of polar or something else. And it can also get high with the help of convectional air current. What it does, it forms a nuclei by the help of hygroscopic formation. It forms a nuclei around the water vapors and helps the water vapors in the forming of clouds. It helps the water vapor in the formation of clouds. Now what we are going to talk next is the structure of atmosphere, which is, there are the 5 main components of a structure of atmosphere, which are: first is the troposphere, second is the stratosphere, third is the mesosphere, fourth is the ionosphere, fifth is the exosphere. Now we are going to talk separately about each of these spheres. So first is the troposphere. Its height is within the 10 to 13 kilometer range or 8 to 13 kilometer of range. It is the lowermost level of the atmosphere. Many planes like aircrafts, jets, like all things, drones, this all passes from this troposphere. It is 8 kilometer above the poles and 13 kilometer above the troposphere, because heat transported in the equatorial region more. Why? Because the sunlight is directly affected on the equatorial region rather than the polar region. It contains dust particles. Also, in every 165 meters of height, 1 degree Celsius is decreased from this layer. It is important for all of the biological activities. Clouds formation also takes place here, and the air temperature is minus 80 degrees Celsius over equator and minus 45 degrees Celsius over the polar regions. It is the place where the climate and weather changes happen. Now the next one is stratosphere. The stratosphere is divided by the tropopause. Tropopause is the region, it is the boundary between troposphere and stratosphere. After the tropopause, the stratosphere began. It is at the height of 50 km high from the surface of the earth. It contains the ozone layer and it is found above the troposphere. So that was about a stratosphere. The next we are going to talk about is the mesosphere. It is above the stratosphere. The boundary between mesosphere and stratosphere is known as a stratopause. Just like tropopause, it is a stratopause between the stratosphere and mesosphere. At the level of 80 km high, the temperature of air is minus 100 degree Celsius. The limit of mesosphere is known as mesopause, which acts as a boundary between the ionosphere and the mesosphere. The next is the ionosphere, which is 80 to 400 km above the surface of the earth, and after the ionosphere, the temperature starts to increase. Now why the temperature starts to increase? Because after the level of ionosphere, we are going to take our step into the space, and in the space there is a lack of atmosphere, there is lack of gases by which the direct sunlight comes. So the temperature starts to increase from here. It contains the ionized charged particles. That's why it is known as ionosphere. Next we are going to talk about that the radio waves that is transmitted from the earth strikes back against to earth because of this ionosphere, because the ions are consolidated, or they collides with the radio waves and transmit those waves back to the earth's surface. After the ionosphere, we are going to the most upper level, that is the exosphere. After ionosphere, there is one more layer, that is thermosphere. But thermosphere and exosphere are very high. They are in the space. If we are in the space, when we look our earth, even if you will see in many images, our earth will look blue. So the blue boundary, the last most boundary after which a space starts, is the axosphere or the thermosphere. After the thermosphere, exosphere starts. We don't know more thing, or we don't know even 5 to 6% of the things about a thermosphere or exosphere, but we know that thing, that whatever it contains, it will be very, very rare for that particular sphere, which is thermosphere and exosphere. After it, we get into space. So thank you, my friend. This was the video.